Have you ever seen a formula that connects the fundamental constant e, the imaginary unit I, and trigonometric functions? Today, we will explore Euler's formula, which elegantly links these different mathematical concepts. You will learn about complex exponentials, understand cosine and sine, and see how they relate through this powerful equation. First, let's look at e, known as Euler's number, an important constant often used in growth and decay calculations. Next, consider the imaginary unit I, which is defined as the square root of -1, allowing us to work with complex numbers. A complex exponential combines e and I in the form e to the power of I times x, where x is a real number. This e to the power of I times x represents a point moving around a circle in the complex plane. Now, let's recall trigonometric functions, specifically cosine and sine. Cosine of x measures the horizontal position on a unit circle, while sine of x measures the vertical position. Euler's formula states that e to the power of I times x is equal to cosine of x plus I times sine of x. This formula beautifully shows that a complex exponential is really a combination of these two trigonometric movements. The real part of the complex number is given by cosine of x, and the imaginary part is given by sine of x. Think of x as an angle in radians that determines the position on the unit circle. Let's try an example. We will use Euler's formula to calculate e to the power of I times pi. Here, our value for x is pi radians. First, find the cosine of pi, which is -1. Next, find the sine of pi, which is 0. Now, substitute these values into Euler's formula. E to the power of I times pi equals -1 plus I times 0. This simplifies to e to the power of I times pi equals -1. A truly remarkable result known as Euler's identity. For practice, consider what e to the power of I times pi over 2 would be. You would find cosine of pi over 2 and sine of pi over 2, then combine them using the formula. To summarize, Euler's formula connects e to the power of I times x with cosine of x plus I times sine of x. It shows how complex exponentials can be expressed using fundamental trigonometric functions. This formula is crucial in electrical engineering for analyzing alternating currents and in signal processing for understanding waves. Keep exploring how this elegant relationship unlocks solutions in many advanced mathematical and scientific fields. Generate your own educational videos for free at eduvids.vercel.app.